sp hybridization. In this video, I'm going to go through step by step in drawing sp hybrid orbital. For example, for BeCl2. First, when you have the molecule of BeCl2, the chemical formula BeCl2, first you have to write down the electronic configuration for both atoms or for all atoms in the molecule. This is the electronic configuration for Be, 1s2, 2s2, and the electronic configuration for Cl, 1s2, 2s2, 2p6, 3s2, 3p5. This is the first step. Write the electronic configuration for all atoms in the molecule. Next, focus on the central atom. Focus on the central atom. Look at the valence electron of the central atom. Our valence electron, 2 valence electron in central atom, because our central atom is Be, 2 valence electron. So you have to draw, the next step is draw the orbital diagram of valence electron of central atom. So this is the orbital diagram of valence electron of central atom, 2s2, and you have to write down this is the ground state. Secondly, write the orbital diagram for electron, for promotion of electron, or you can write down excited state. So, for promotion of electron, you have to look at the bond that the central atom has. This central atom has 2 bonds, 2 single bond, 2 sigma bond. When the central atom has 2 single bond, this central atom needs 1 unpaired electron to be bonded with each chlorine. So this Be, 1 unpaired electron to be bonded with this chlorine, and this Be, another 1 unpaired electron to be bonded with this chlorine. Means this central atom requires 2 unpaired electron. In the ground state, the valence electron Be has 1 pair of electron. This electron is in pair. These 2 electrons are in pair. But for excited state, you have to look at how many bond does this Be has. So this Be has 2 bond, means it needs 2 unpaired electron. In promotion of electron, you have to split this electron to be 2 unpaired electrons. So you take this 1 electron, put in the higher orbital, which is 2p, because 2s, 1 pair, so put in the empty 2p orbital, making 2 unpaired electron. Okay, this is the second step, making 2 unpaired electron. And then, lastly, when these 2 electrons are mixed, 1 electron into s orbital, 1 electron into p orbital, mixed together, resulting in sp orbital. Because 1 electron from s orbital, another electron from p orbital. So that's why the name is sp orbital. When you mix these 2 orbitals together, it becomes sp orbitals. And this is sp hybridization. Write down sp hybridization. And this is the orbital diagram of sp hybridization, leaving 2 empty orbitals. You have to write down these 2 empty orbitals. And then, this is the energy level diagram of sp hybridization. First, you have 2 electrons into s orbital and no electron into p. Initially, this is a ground state. And then when you mix these 2 electrons together, because you have to make 1 unpaired into s, another unpaired electron into p, mix them together, making sp orbital. If you carefully look at this sp hybridized electron, the energy level is in between. It is in between 2s orbital and 2p orbital. Energy level diagram, 2s orbital has lower energy than 2p. That's why 2p is on top of 2s. when you mix them together, when you mix orbital S and orbital P, resulting sp hybridized Be atom. So the energy level of sp hybridized is in between of 2s and 2p. 2p is higher, and then sp is in between of 2s and 2p, leaving this empty 2p orbital, 2 empty 2p orbital. Initially you have 3 in totals empty 2p orbital, and you use 1 to make it hybrid sp, so leaving 2 empty 2p orbital must be in line with 2p because they have the same energy level. Empty 2p must be in line. So 1s orbital mixed with 1p orbital, you will get 2 equivalent sp. So this 1 sp orbital, 2 sp orbital, 2 equivalent sp orbital. Both sp orbitals are in the same energy. Energy level of the hybrid orbital is in between energy level of pure orbital. This is pure S, pure P. sp hybrid is in between those two pure orbitals. Each sp orbital has one unpaired electron. Here, one sp orbital, one unpaired, one sp orbital, one unpaired. So it's like you're mixing 2s and 2px because it only involves one type of p orbital. You have 3 p orbitals in total, but it only involves one type. So let's say it's 2px, 2s mixing with 2px, resulting 2 sp orbital, 1 sp orbital, 2 sp orbitals, resulting 2 equivalent sp orbitals. This is the shape of sp hybrid of central atom Be. One sp hybrid orbital with one unpaired electron, and another one sp hybrid orbital of central atom with one unpaired electron. So this central atom has one unpaired electron each before bonding with Cl. So in order to form a bond with Cl, this chlorine need one unpaired electron to be paired with this electron. And this chlorine also require one unpaired electron to be paired with this electron in sp orbital. So we have to draw the orbital of Cl. First, you have to draw the orbital diagram of Cl. If you look at the orbital diagram of Cl, the position of unpaired electron, because in order for you to form this bond, this Cl require one unpaired electron to form bond with this unpaired electron of Be central atom. If you look at the position of unpaired electron of Cl, it is in p orbital, 3p orbital. So you have to draw the p orbital. P orbital shape is dumbbell. So you have to draw p orbital for Cl with one unpaired electron like this. So this is 3p because the unpaired is in 3p orbital. So the shape is dumbbell shape with one unpaired electron and then pair with one unpaired electron in Be, forming sigma bond. Make sure you write down 3p because this electron, this orbital, 3p orbital, and the unpaired electron in 3p orbital, and write the sigma bond here. These two electrons pair together to form sigma bond. And another side, another sp orbital unpaired electron will be paired with chlorine, another chlorine with unpaired electron from 3p orbital. So you have to draw the shape of 3p orbital of Cl paired together to form sigma bond. Make sure to write 3p because it's in 3p, not just p orbital because you don't know whether it's 3p or 2p. There's no unpaired electron in 2p, that's why you have to specify it's 3p orbital. Each BeCl bond or sigma bond, this H bond, formed by overlap of one sp hybrid of the central atom Be and one 3p orbital of Cl atom. So the hybrid, one unpaired from Be, one unpaired from 3p. This overlap. forming sigma bond. So both sigma bond is formed by orbital overlap of 3p and sp. Two equivalent sp hybrid orbitals that lie 180 degrees apart. So this is 180 degrees apart, the bond, these two bonds 180 degrees apart, because this central atom has two electron groups. When it has two electron groups, the electron group is linear and the central atom has no lone pair electron at all. So the molecular shape is the same as electron group arrangement, which is linear. That's how you draw step by step of hybridization as P.